Swayam Prabha. Digital India. Educated India.
After the introduction lecture to this particular module on ferrous and non-ferrous metals, we will move on to the particular ferrous metals, particularly discussing on cast and wrought iron. Now, what we understood in the first lecture is metals are quite different than whatever other items we had discussed so far in the previous 5 modules. So, there we understood that metals have much higher embodied energy. It requires lot of exploration to get it. So, we get or retrieve the metal from the ore, and then we have to go for high energy, and hence the embodied energy increases. But yes, it is 100% reusable. It has a larger life span and you can continuously use it without much loss, which was not possible for all other materials discussed so far. Other thing is metals are malleable, ductile, they can take lot of tensile strength, which was along with compressive strength, which was not much taken other than the item wood. So, we will move on to cast iron and wrought iron in this particular lecture, because these two are the very preliminary use we find of these two items, the cast iron and the wrought iron. I had shown you examples of the Eiffel Tower, which is made of wrought iron, the Statue of Liberty, inside of it is made of steel, made of wrought iron, and cast iron bridges were the very initial steel structures. So, first we come to these two, we covered these two in this lecture, and then we will move on to the steel which is more used nowadays. Now, first coming to how we extract the ferrous metal, we will be very brief in it, and then we will go particularly to see the extraction of pig iron, and then cast iron and wrought iron with its characteristics and uses. We will try to cover these in this particular module. So, ferrous metals are those which contain iron, and iron can take higher tensile strength compared to the non-ferrous metals. That is why we use iron so extensively in our buildings, although it has many other drawbacks. So, we will open up through this module on different aspects of iron. Now, coming to the melting of its ore, we have to know what are the ores. The magnetite, the hematite and the iron pyrites are majorly the 3 ores found extensively in many parts of India, and we get around 75 to 60%, say 60 to 75% of it is iron content. But how do we get that iron? So, principle of getting the iron is heating the ore. That is, you are in presence of a reducing agent. So, you are reducing the ore, and then carbon dioxide, carbon monoxide is evolved, and iron is extracted in maybe a crude form. This first stage extraction is called pig iron, which is the input to either cast iron or wrought iron or steel. So, pig iron is the first processed iron ore, and pig iron can be used for making other irons. So, pig iron is nothing but to initiate the production of cast iron, wrought iron or steel, we need to have this first extraction from the iron ore. So, we treat it further and we get all other forms. Now, let us come to see the let us try to know the process of smelting, which is actually extracting the metal from its ore, which involves heating and melting. So, what we will do? We will take the ore and we will try to heat it and melt it up to what temperature at which it will melt. Limestone is added as a flux or an additive which actually reduces the melting point. It has many other aspects. It helps in removing the impurities like sulfur. It also helps in a formation of a froth or a slag which is lighter in weight and separates out from the molten metal. So, the lighter material comes up which contains lot of impurities and that can be actually tapped out, whereas the molten metal sinks down because it is heavier, its density is higher and it sinks down and that can be separated out. So, limestone plays a key role in the extraction process and it is called as flux. So, what we see that during this process of smelting, that is heating and melting, the flux plays an important role and we get the item which is pig iron or cast iron or wrought iron or steel, whatever it may be, but because of the heating process the entire material, that is the metal in liquid form, attracts lot of carbon in it. So, we also need to look for to extract or keep the carbon lesser in amount, and this carbon is the key player to make or change the properties of the metal iron. So, less the carbon, purer is the iron and it is more in strength. Higher is the carbon, it is more brittle in nature. However, we have to have carbon in it because carbon helps or carbon contributes towards the strength of the steel also. We are using the term steel, iron, but they may be understood as the same. So, pure iron will be soft but will significantly harden due to the impurities. So, carbon is the major impurity. Other than that, it is silica, magnesium, phosphorus, sulfur. As I told, limestone attracts sulfur and reduces the sulfur from it, reduces the amount of sulfur or percentage of sulfur from the ore. Carbon varies from, you can see, that is 0.002% to 4%. So, by varying different carbon proportion, you will get different types of iron. And this carbon, as I told you, is trapped during the smelting process, that is the heating process. And as you all know, we know all metals can alloy with other metals. I have discussed this in lecture 1 and you can get various properties. Another beauty is of metals, you can treat it with heat and you can get different properties of metals. So, heat treatment can be done, alloying can be done, different varying carbon percentage can be considered and we can get a large type of iron. So, we need to know all of them. Now, coming to the types, how iron exists in its physical form, you have all studied in chemistry the allotropes. Iron has 3 allotropes: alpha, beta, alpha, gamma and delta at normal temperature. but we are not much concerned with this. These are more for the metallurgists. What we are concerned is on three types: cast iron, wrought iron and steel, which is mostly categorized based on the carbon percentage. Now you see cast iron, you see it is varying from 1.7 to 4.5. As I told you, up to 4% is carbon content. Cast iron is very brittle. Wrought iron on the other hand has less than 0.15, that is, if you remember, 0.0002%, starting from there to not even just 0.15%, not even 1%, whereas steel you see it is between 0.25 and 1.5%. So, not all cast iron and wrought iron will be very much useful for structural purposes, whereas steel, where we see it is only a small window of carbon percentage from 0.25 to 1.5, there we get a lot of variety. As we proceed, we see that cast iron, which is at the top of the table, and wrought iron, which is at the other end of the table, and we see steel in between. So, cast iron and wrought iron are totally opposite in their character, and you see the ease of welding, you see wrought iron is the easiest, whereas cast iron is easy for casting, wrought iron cannot be cast, hardness of cast iron is very high and tensile strength of cast iron is also very high. But remember, I told you, because of high percentage of carbon, cast iron is brittle in nature. So, whatever high be its tensile strength, it may fail without any notification to the structure. So, you can make a cast iron item having high tensile strength, but it may fail because of its structure, brittle structure. Vice versa, wrought iron won't. We will come to that. Now, coming to the manufacturing of pig iron. You see, this is a picture of a blast furnace. What I told you, the ore is first put in. If you see, the ore or the charge which we already discussed is pushed up with a conveyor belt. These items are very heavy, so the conveyor system is there which puts in the charge at the top of the furnace. And you see here in this portion, the iron ore is, the charge is getting accumulated, and here are the tiers through which the hot air comes in. If we see, this hot air is blown into this charge which is limestone, iron ore and coke. So, this hot air is actually heating the entire charge, and this eventually melts the iron ore and the coke gets burnt, and the limestone separates out a number of impurities. So, what you see here at the bottom is a slag hole and this side is a tap hole, and you see the slag hole is at the upper level, whereas the tap hole is at the lower level. This is to tap out the metal and this is to tap out the slag. So, if we go see that limestone is attracting the impurities and slag is lighter and floats on the top. So, slag is tapped out through the slag hole, the metal which is called the pig iron or the first extraction is taken out from the tap hole. So, this molten iron and slag is tapped at regular intervals and the charge is continuously poured from the conveyor belt at the top, and the process goes on. So, we get pig iron which now goes into the manufacturing of cast iron. You see the similar picture where you see the metal and the metal and the flux and the coke, metal, flux, coke, metal, flux, coke are charged from this charging floor. So, on top is the stack where from these things items are charged one after the other to form a mix. And here also the same process is followed. The pig iron is remelted and you can again see the air is blast inside through these tires, and you have a slag hole, you have a tap hole. So, this is called the cupola furnace, and after this second round of extraction, that is kind of purification, remelting, you get cast iron. Some old cast iron item is added into the charge so that the cast iron forms very quickly. As I told you, it is crystalline structure. Let us see the structure. You see, it is mostly a very grainy structure, columnar grains and oriented in a single direction, so you can break it just like a biscuit. So, here you can see that at any point it can crack or break, and this is the problem with cast iron, though it has very high tensile strength. Now, coming to the properties. Melting point is lower, lesser the carbon, higher the carbon, lesser is the melting point. Carbon percentage, as I told you, 1.7 to 4.5, strong in compression, weak in tension compared to its compressive strength. But you will see wrought iron has lesser tensile strength than this 150 Newton per millimeter square. It is around 40 Newton per millimeter square. It is brittle and hard, does not absorb shock, so it suddenly fails without warning. You may see some cast iron pipes in old buildings, a part of it is there and part of it is detached. So, those are actually failure of cast iron where no warning is given, hence it is used for such rainwater carrier, which won't affect the system much. That is, it is not having any structural, it is not used as a structural member usually. But it has, you see, it is strong in compression, it takes quite high compressive strength. It can be cast into various shapes, it has a shrinkage. So, when it is cast into a mold, it shrinks and it comes out very easily, and you cannot do any kind of joinery, we will elaborate it later, riveting, bolting, welding, nothing is possible with cast iron. It cannot be forged, that means bent or hammered or shape changed. So, these are the salient properties of cast iron, and we come to again the three types of cast iron. These are to mention: grey cast iron will contain more amount of carbon, white cast iron is having lesser amount of carbon, and malleable cast iron is having further less amount of carbon. Malleable means it can be pulled out, it can be rolled out, it is less brittle, it is resembling more towards wrought iron, it is having its carbon content is lesser. Now, coming to the extraction of wrought iron, you see here it is a reverberatory furnace. So, what is happening? The heat is actually not, the coal is actually not with the charge. So, here this portion, you see, D is the fireplace, this portion is the fireplace, that is, this portion is the fireplace where the coal is burning, and this is the portion where which is this hearth where the iron ore is kept, that is, the pig iron is kept, not iron ore, the pig iron is kept. So, this heat is generated and it is continuously falling on the iron, on the pig iron. So, this coal or the coke is not coming in contact with the iron ore. This is an indirect way of heating, and hence what is happening? The carbon from the coke is not getting entrapped into the pig iron or the molten iron. What is it benefiting then? The carbon content is lower, is much lower, because it is not contaminated by the coke, which was happening in case of the blast furnace, also in case of the cupola furnace. So, that is why this is called a reverberatory furnace, where the heat is reverberated, or it is coming again and again from the ceiling of this furnace and melting the pig iron, and the pure form of iron is extracted out. So, once this iron from the pig iron here gets molten, it is getting gradually extracted out, and this is how the wrought iron is obtained. So, what you understood is the reverberatory furnace is such a furnace where the pig iron is not coming in contact of the coke, and hence pure form or the purest form of iron is obtained, which is called wrought iron. Now, let us see what are the properties of wrought iron. Now, you see the structure again. This is again rounder, more uniform structure. You can now distinguish between the cast iron structure and this wrought iron structure. So, obviously, there is a change in the structure of the iron with the change in percentage of carbon, where in wrought iron carbon percentage is negligible. And as I told you, the melting point of wrought iron is higher. Cast iron was 1250, whereas melting point of wrought iron is 1500 degree centigrade. Wrought iron is tough, malleable and ductile. It is resembling more properties of steel, and it can be welded at 900 degree centigrade. We will come to welding, where we will discuss what are the types of welding and how the joinery happens in metals. It can be, the other important point is, it can be bent, twisted, both hot and cold condition. So, you can forge it, you can forge wrought iron, and that is why you can make many ornamental items just by forging or twisting wrought iron. And wrought iron furniture, wrought iron gates, wrought iron street furniture are being made. It rusts more quickly than cast iron, but it can stand salt water better than cast iron. You see here the compressive strength has gone down from 600 in cast iron to 200 in wrought iron, and you see tensile strength has also gone down to 40 Newton per millimeter square. But its properties of metals are more in wrought iron. So, here are some uses, and we can see a number of pictures. What you see here is the pipe, the rainwater pipe which I was talking, that is a cast iron item. You can see the grating is also of cast iron, that is where the water is coming and getting accumulated. Many of you have seen this kind of manhole cover on roads, even at your residence. These are cast or made out of cast iron. So, this is sitting on a surface, people can walk on top of it. Even if it breaks or cracks, it will not create any problem. So, it can be used for such purpose. You can get cast iron staircases. Usually spiral staircases in old buildings were made of cast iron, and sometimes one or two of its steps just fall apart. So, it stands beautifully where it is, but it may break without giving you any warning. On the other hand, you see the items made of wrought iron. You can see such ornamental street furniture, the lampshades, the projecting brackets. These are not cast. These are all twisted and made out of wrought iron. You can see wrought iron garden chair, table, etc. You can see street furniture on road, those are usually of wrought iron. So, any kind of ornamental works can be made with wrought iron. So, we can conclude that cast iron has higher compressive as well as tensile strength, and earlier it was used for bridges, large spans. Wrought iron is the purest form of iron with negligible impurities, hence it is forgeable easily. Riveting, welding, etc. can be done on wrought iron, which is not possible in case of cast iron, but presently we see steel has replaced most of it. But these items, some which I have discussed, I had shown you in the previous picture, are still being practiced made of cast iron. We can get lots of tools made of cast iron, and hence it is not erased completely, but yes, its use have lessened to some extent with the, and steel has taken its place. So, we will in our next lecture move to steel. Thank you.